All right, Algebra 2, Lesson 13, we're going to talk about graphing linear equations. This is the first set of this. Probably in a couple of lessons we'll look at it again. So an equation like y equals 2x minus 3 is a linear equation in two variables. We can use an ordered pair, x, y, as a solution to an equation in two variables if substituting the values for both x and y into the equation produces a statement that is true. So for example, if we plug in 4 for x and 5 for y, we would get 5 equals 2 times 4 minus 3. 2 times 4 is 8. 8 minus 3 is 5. Therefore, we have a true statement. All that means is that the coordinates 4, 5 are on the line represented by y equals 2x minus 3, where minus 3 is the y-intercept, and 2 is my slope of up to over 1. Okay, are we somewhat familiar with slope-intercept form? A little bit. Okay, good. So whenever it comes to graphing equations in two variables, I'm hoping that this is something that we're familiar with. You can construct a table of values, choose a reasonable value for x, and solve for the equation for y. So you substitute a number in for x, and get your y answer. Okay, and then you can repeat that, and then plot all of your individual points, and then connect all your dots, and that's a way to graph your line. You can plot the points represented by the solutions to the equation, which is coming from number 1. Connect the points, extend the line, draw arrowheads at the ends to indicate that the lines extend off into infinity, which means we just keep going. That's a way to do it. I'm not saying that that's the most efficient way to do it. I think probably the most efficient way is probably the way that you already know, which is plot the y-intercept point and then use your slope. Whether it's up and to the right or down and to the right, but plotting your slope points are probably going to be maybe the quicker way than to solve the equation 5 or 6 times, plot those points, right? You see what I mean? All right, so the points where the graph intersects the axis on the coordinate plane are called the intercepts. So we're most familiar with the y-intercept. There's also an x-intercept. The point where the graph intersects the x-axis is my x-intercept. The point where it intersects the y-axis is called the y-intercept. That's the one you're most familiar with using. Okay. So to find the x-intercept, you let y equals 0, and then you solve the equation for x. One way of being able to plot a line is to find your x-intercept and to find your y-intercept and to just draw the line between those 2 points. Okay, you can do that. Okay, fine. So you would let y equals 0, solve the right-hand side for that. Okay, for the y-intercept, you let x equals 0 solve the equation for y, which is typically just it's your y-intercept. Okay, plot and connect the intercepts, extend the line and arrowheads to the ends. Okay, slope of a line. Let's see, I need to fix this. I'm going to go ahead and do this now. Somebody earlier today caught this. Okay, our formula for finding slope uses our coordinates. So if I have 2 coordinates and I want to know the slope of a line, I'm going to take the y2 minus y1 and x2 minus x1. Now, just like what we talked about finding the distance between 2 points, okay, does the distance between 2 points change if I'm finding from A to B or the distance from B to A? No, it doesn't change. So it says y2 minus y1 and it says x2 minus x1, but it doesn't matter which one is y2 or y1 or x2 or x1, just so long as I don't flip them. Okay? So I can do y1 minus y2 so long as I do x1 minus x2. Okay, do you understand? It's not going to change your answer. Okay? But that's giving me my rise over run, which is why we're doing y over x. I would say that that's the part that people get most confused about, is that we're doing y over x instead of x over y. And the reason we do y over x is because when we're talking about coordinates, okay, y is representing my up and down movement, rise over run, slope. Okay, run is my x-axis. Okay, so I have to do y over x. Any questions so far? No, we understand this. I would say that what gets confused with this is the midpoint formula. Right, midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Right, because we see that we're doing something with y1 and y2. We see we're doing something with x1 and x2. Right, we're just forgetting which one is midpoint, which one is slope. Okay, so midpoint and slope are often commonly confused, right, when we don't study our formulas. Slope-intercept form may be one of the, besides the Pythagorean theorem, one of the handiest equations that you'll get down, which is y equals mx plus b. What does m stand for? Slope. Okay, slope is rise over run. Okay, b is what? Y-intercept. Okay, the x-coordinate of the y-intercept is what? Anybody know? What's the x-coordinate of the y-intercept always? 0. Okay. All right, so a linear equation written in the form of y equals mx plus b is written in slope-intercept form. M is the slope of the line, b is the y-intercept. In this equation, right, the slope is negative 2/3, which means if I had my y-intercept, which is positive 4, what am I doing from that coordinate of 0, 4? What am I going to do? I've got the coordinate at 0, 4 for my y-intercept. Where do I go from there to plot the line? Go down 2, and what do you mean by over? Do you mean to the left or the right? To the right. So down 2 to the right 3. Now I plot that point. What do I do after that? Repeat. Go down 2 over 3. What if there's not enough room for me to go to the right? Can I go to the left at all? How do I do that? Go up 2, left 3. Okay, good. So we have an understanding. A line can be graphed using the slope-intercept form by plotting the y-intercept first, using the slope to move to plot another point. The slope is like a set of directions to indicate how many units to move and in which direction. But we understand that. Okay, so let's look at this. Okay, just to make sure that we've got an understanding, and I'll let you loose. Let's double check on what time you guys are typically out of here. Looks like 10:11, so not a whole lot of time. All right, find the intercepts. So this one's the intercepts of negative 5x plus 4y equals negative 40. All right, what did they say I needed to do to find the x-intercept? Make the y 0. Okay, so if I make the y 0 in this case, right here, what's 4 times 0? 0, so that pretty well cancels it out, right? So now I just need negative 5 equals negative 40, right? Well, what times 5 equals, well, let's divide by negative 5, right? So x equals 8. So what we're saying there is that the x-intercept, where it's going to cross the x-axis, is there. Okay, now I'm not saying that that graph is correct, but I'm just using it to plot my point. All right, now if I wanted to find the y-intercept, okay, what do I do? Set x to 0. Well, what's negative 5 times 0? So that gets rid of that, right? What do I need to do to solve for y? Okay, what's negative 40 divided by 4? Negative 10, okay, which means on the y-axis I'm at negative 10. All right, does A work for my answer? Right, now I'm just connecting the 2 points. Okay, so it usually gives me a pretty good picture just solving my x and y intercepts. And that's something that we'll come back to later when we're dealing with something called, I'm trying to think of the term for it. But whenever we have limitations and bounds and we're dealing with data. Okay. All right. Let's see, do you guys feel like this is fairly review information? Okay. All right, so if you like, I'll stop there. Let's do one question here. We're actually using the slope formula, though. We got 1, 6, and 10, negative 9. Let's see, Allison, help me find the slope of this, okay, using our formula. Okay, negative 9. Okay. Okay, what's negative 9 minus 6? Okay, Eric. Negative 15. And what's 10 minus 1? 9. Negative 15 ninths. Does that reduce? What can I divide both those numbers by? Okay, negative 15 divided by 3. 9 divided by 3. Okay, now just so that you know that I'm making my point clear enough, if I did this the other way around, where I did 6 minus negative 9, right? 6 minus negative 9 and 1 minus 10. Well, what is 6 minus negative 9? Positive 15, right? What is 1 minus 10? Negative 9, but where does the negative go in a fraction? Goes up, right? Do I end up with the same answer? Okay? All right. Just wanted you to be able to see that. All right.